York and also for the United Nations as a whole. So this is the content of what we're going to cover in our forecasting, our presentations today. Positive percentage is defined as the total number of positive tests by the total tests performed, and it has a threshold of 5%. So anything that is less than 5% is considered to be okay to open the economy, but if it is close to or greater than 5%, then it is too high, and it's probably not the best idea to go ahead and loosen the restrictions. So our data source comes from the Data USA, and so our initial EDS shows that there is not much missing values. That has some missing values, but not large enough to make any significant changes in our final presentation. So the positive percent data looks to be right skewed with total mean percent positive of 15.05%. And for the chart on the right, you can clearly see that April was the worst month, but good news is that it's slowly decreasing with November being the best month. In terms of positive percentage, we want that to be continuing. So the realization looks non-stationary, and you can see the ACF is slowly damping ACF, and the spectral density is at 0, which is mostly dominated by 1 minus B factor, which we believe is in there. So what we did, we trimmed the data set, and the trim data looks close to the XO1. So we overfitted the data to find out if there is a 1 minus B factor, and clearly from the factor table, you can see that there are 2 1 minus B factor present. So we differentiated the data twice, and we build our model on the difference data. And this is the model. We went with the lower order ARMA 2.0 model. And here you can see the parameter estimate for our model and final fitted ARIMA 2.2.0 model, which we're going to use for our forecasting. We check the model appropriateness by looking at its residuals. Here from the plot, you can see that it might be a white noise, but again, young box text, both of them actually rejected the null hypothesis, so it's actually not white. But we're going ahead with our forecasting anyway, even if it is not suggested that the residual is white. So we did both long-term and short-term forecasting. So based on ASE, clearly short-term forecasting is much better than the long-term forecasting using our non-stationary 211. So this is our rolling window ASE showing the seven days forecast, and you can see the mean ASE of 0.55. And we're trying to show the final forecasting using our ARIMA 2.2.0 non-stationary model for both 90 days and also for the 7 days. The one that is highlighted in red is the forecasted value that we did. And we also use the non-stationary model just to compare, and the forecast using a non-stationary model is actually trending towards the mean, and we don't want that to actually go there. So a positive percentage for the US, again, looks to be right skewed with some outlier. Total mean percent positive is 10.73. It's much lower than what the New York has. So the time series is again for this US is kind of wandering with slow damping ACF, spectral density at 0, which is mostly, we believe, because of the 1 minus B factor that's present in our data set. So we overfitted the model to check for 1 minus B factor, and you can clearly see from the factor table that there might be a 1 minus B factor in there, which is also suggested by the Dickey-Fuller test. So we difference the data twice, but we're going with only the first differences for modeling purpose. So so based on AIC, we're going to go ahead with ARMA 611 because it is common in both AIC and BIC. So this is a parameter estimate and a fitted ARMA 611 model that we're going to use for forecasting. So our residual doesn't look good. It don't look good. We don't see that it's widened, which is both suggested by the first check and also for young box test, which actually rejected the null hypothesis. But we're going with forecasting. So the short-term forecasting is actually much more better based on ASE compared to the long-term forecasting. Here you can see that ASE is lower. And this we're showing the rolling window ASE for short-term 7 days forecasting. You can see the mean ASE is 0.25. We also build the stationary model, ARMA 611, and the forecast based on the stationary model is actually trending towards the mean. Here we're trying to compare both non-stationary and stationary model. So for the long-term forecasting, you can clearly see that non-stationary ARIMA 611 is better than stationary. Here you can see the 90 days forecast for both positive percentage for long-term and also short-term 7 days positive percentage using our non-stationary model. So this is definitely not best model. So we're going to do a better job by using different other model like VAR, NNN, and many other in our coming presentation, in our final presentation. Thank you.